Hi, Mr. Anwar and Patrick. I'm gonna introduce a bit about my technique to optimize the EXE, the existing software, by enhancing through machine learning, prediction, and statistical analysis. So the problem is how can we optimize the pre-existing software to detect uncertainty, things like that. And the goal is to predict the failures before they create something wrong to the custody transfer, so we can save the losses. And methodology, I'm going to do machine learning and deep learning to increase the accuracy of the model. And I'm going to present to the EXE using .NET, the executable file, so allows the client to do installing the software and then doing like the predictions. So it's like statistical analysis using the correlation. So we have like the normal bias and uncertainty. Again, it's like disclaimer, just run using the simulated data. So after training and testing, we have like the accuracy, event score, recall, and other metrics of supervised machine learning, in particular classification. So we have XGBoost, AlphaBoost, and deep learning using a bit better accuracy. So, and we have like the training loss and accuracy with um, better accuracy of the result here, the normal and fault to predict like the default predictions. And it's like the example of if we have like a higher volume and then gas price, so we can save more potential losses. And he's like the simulated data. And actually I used to apply like the react js and as the front end and the back end using python and api, so we can do like the predictions doing like this tech stack. And he's like something that I'm gonna um, discuss. So here's the exe file. After installing the exe file, that I manage the tech stack, the pipelines, so the client can do this kind of predictions. So they can do like uh, doing classifications, yeah, to increase the accuracy. And here's like the file of .exe, yeah, that I set up using the .NET. It's like complex thing here, bit complex. Yeah, let me show. Yeah, so after manage, like the .NET and ML.NET, so we produce .exe. So the client can use this executable file, yeah, to run this machine learning model without worrying too much about the data migration to such a cloud technology. So they can just keep the data on their existing ecosystem. So it's like this start live streaming. So we can do deploying the model of machine learning. So after doing this kind of pipeline with a Python Jupyter notebook, by enhancing fault detection earlier, so we can reduce the loss earlier, so we can bring the value to our customers by applying to machine learning model. We can also increase the accuracy to reduce engineering hours. We can also enhance the false positive up and the context awareness. And by doing such a calculation of response factors, so I saw your paper, Mr. Alvar and Mr. Patrick. Uh, so I think that allows me to get a bit better understanding about this context. But yeah, I acknowledge I was process engineer, but I just like, I have like a bit understanding about their context. But again, we can do such collaboration to enrich the data input validation. But at least, yeah, I've demonstrated my know-how, my visions. How can I bring value to your customers? That's the goals. And how can we create, like personalized software with the AI, machine learning, yeah, to increase the accuracy, yeah, to avoid, like the losses earlier. That's the value that we are going to bring to our customers. And as data science and AI consultants, I used to manage, solid teams to do like pipelines. Even I used to apply, yeah, by myself, yeah, to detect, facial trend to so detects signals out of noises, so we can find out linearity, hexons, residuals to detect like foul health and gas compositions of methane, ethane, hexane. And it's like simulated data. So but my proposition is, how can we use automatic machine learning and automatic fine-tuning model to increase our model accuracy, yeah, recall, precision, area under curve, and other yeah, model accuracy, yeah. So avoiding, like the overfitting, not either underfitting. So we can have the optimal model, yeah, to bring real value to our clients, and it's like the feature importance, so we can find out which kind of the top five variables that truly matters, yeah, to affect, like the predictions. So we can show like the confusion to file.exe, our pre-existing file as the plugins, yeah, to enhance level of understanding our client about the machine learning the prediction, so they can detect signals earlier to avoid losses, yeah, to save, to increase efficiency, things like that. And after that, they can do like scenario, yeah, that close to the real scenario. So they can do, like various scenario of analysis in terms of linearity, hexagon, and additionally, we can enhance by adding other features, other variables here. For instance, if we get better linearity of the model, yeah, so the diagnosis analysis shows the healthy conditions. But if we get worse linearity down to like, yeah, around 2%, and also we have the fault. And after running this kind of the model, so we can use like live streaming here and to detect, yeah, the class based on our model. So we have the normal, all of things like that, and then